So thank you for coming to this talk, in which I will tell some stories. So one hill I'm ready to die on is that whatever you can hear, cybersecurity can be tough, and especially application security, which is the field of security I know best. It can be tough to understand for junior developers. So, for instance, this is an extract, not even the full page, of the OWASP cheat sheet on how to prevent SQL injections. And so it's a bit difficult to grasp. There are lots and lots of things to learn. It can also be difficult to prioritize. I guess many of them have had to negotiate to make a project team prioritize security features before business features. And there is something, we as human beings, we are flawed. There is something that's called the optimism bias, which is our tendency to overestimate the likelihood of positive events and to underestimate the likelihood of negative events. And so often, of course, we've all heard about flaws and vulnerabilities and breaches and attacks, but as it doesn't happen to us every day, we have the tendency to think that it always happened to others and not ourselves. And in fact, it's an evolutionary trait. We've evolved to be like that. If we knew and thought of all the things that could happen to us if just we crossed the road, we would always stay home. But evolution gave us some weapons to fight these traits. And there is one thing that we've dealt with for centuries, long before cybersecurity was even a thing, is to meet up around the campfire and tell the stories, to have the other people of the group know what dangers we had to face and how we could avoid them. And so it's even studied by a neurologist and biologist to understand how, in an evolutionary way, we are wired, our brain is wired to understand and react to stories. And that's something that I personally like, because I grew up with stories. So does anyone here know of this? So it's a French animated series. In English, it would be called Papa Beaver, and it's a series in which the beaver, which is a dad, he tells stories to his children, and at the end of each story there is a moral, and so the children can relate to it in their own lives, and we as viewers, we can also relate to them in our own lives. So why am I interested in storytelling in cybersecurity? So I work in a company which is called Theodore, in which we build web applications. So I've been a web developer myself for many years, and as I've always been passionate about application security, I've helped more and more projects build secure products. So I'm a NOWASP member in the France chapter, as my accent can tell. And I am now the CISO at Theodore. So one of my jobs is to help the developers build secure products. And for that, I like to think of myself as the Papa Beaver, because I tell lots and lots of stories of vulnerabilities and flaws and how our developers can avoid them. And the first challenge I had to overcome is, and I still have to overcome it, is that often developers are not very interested in security. There are many fields in web development, such as the speed, new shiny frameworks, that are really more interesting than security. And for me, security is very fun. It's like a game in which you can find flaws in things that other people build. And so one example of that, it will be my first story. It's not even in a web application. It's a real life flow, and it's how you can send letters via the French post system without paying. So there are two features which are really nice in the post system in France. You are able to send letters without paying them. So when you want to pay letters, you buy stamps and you stick them to the envelope, and that's how you pay the post. But you have also the possibility to send a letter without stamp, and it's the receiver, if they want to get the letter, who will have to pay the post. Another feature is the post allows you, as a user, to make mistakes. You can write fake addresses or wrong addresses with mistakes, and if the post is not able to deliver the letter, they will send it back to you. If you wrote the sender address on the back. So, if we combine those two features, let's say you send the letter with a fake address, an address you know that doesn't exist, and on the sender address, you write the address of the person you really want to send the letter to. So the post will try to send the letter to the fake address. As the address doesn't exist, it will fail. And so the post will return the letter to the person you wanted to send the letter in the first place. So it takes a lot of time, and there are double, twice as many chances that the letter is lost. And today, anyway, we don't have to do this because we can send mails and it's free. But it works. And of course, I don't advise doing it. So security is fun. It's fun, but sometimes it's difficult to understand. There are some vulnerabilities and flaws that are hard to grasp. And one example of them is unsafe or insecure deserialization. So for a long time, I've known about this, but I told myself there is no way that some developers will trust the serialized content and parse it on the server side. And another thing that is that can be difficult to understand, how to design, is allow lists. So allow lists are often always better than deny lists, but sometimes it's very difficult to build because there are lots and lots and lots of items that you want to allow, and sometimes an infinite amount of items that you want to allow. And that's why a few years ago, Spring for Shell happened. So it's not Log4Shell, which is very well known. It's a bit less known attack. But so it was a vulnerability in the Spring Java framework, which would allow, using insecure deserialization, it would allow an attacker to have a remote code execution. And so how does it work? It leverages a feature of Spring, which is called data binding. So it's a feature, basically, it takes the HTTP request of a form, it takes all the attributes, all the fields in this form, and it passes them to attributes of an object that you want to handle on the server side. And in Java, all objects that inherit the object have access to an attribute which is called the class attribute. And if you have an Apache Tomcat project, the class loader has access to other attributes. So what you can see on the second line, it's related to a feature in Tomcat, which is basically there for logging purposes. But by using that, you would be able to build a file on the server. So in the example, it's called shell.jsp, and the content is a web shell. And so you would be able to execute code as an attacker. So it was a long time ago, in 2010, and at the time they blocked it. So they blocked it with this code, So they look at the attributes that can be in a form, and if they see something that looks like class loader, they ignore it, and it's not mapped in the final object. So everything went well until 12 years later, because a new feature had been added to Java, which is called the modules. And so thanks to the modules, you have a new way to access the class loader attributes, which is not the class.classloader, but the class.module.classloader. And in the fix that we saw, they hadn't thought of that. And that's why it's very difficult to design allo lists, because you have to think of all the possible cases in the present, but also in the future. And in the future, the code base will evolve. So they fixed it again. And this time, they used an allo list principle. So if there is an attribute behind the class attribute, they say we only deserialize it if it contains name. And this way they are pretty sure that it will not be exploited again. So it's a great way to introduce developers to how it could happen in the real life, deserialization. And also how to do allo lists properly. Because, of course, you can enumerate items, but you could also do allo list programmatically by saying items inputs must start with something or end with something, or even use regex to build them. So it's very easy as experts to do some theory crafting and think of how things should be done only by thinking. But I think it's on the field by having a look at real vulnerabilities that you can find the best ways to protect against some flaws. And so one example of that is, so imagine you have this XSS situation. So an attacker is able to fill a payload. The server stores the payload, and then when a user visits a page on which the payload is displayed, it's executed in the browser, and it's parsed and executed. So you have this flow. Where do you fix it? So you have many possibilities. You could fix it on the client side at the place where the user enters the input. You could do some input validation just before storing it in your database. You could also encode the payload in the API, so after getting it for the database, but before giving it back to the browser. Or you could also encode it when the page is rendered. And so a few years ago, that's something that happened in Evernote. So if you changed the name of a picture attachment in a note, and you added some JavaScript in it, it was executed when you loaded the image in the note. So they fixed it, and they choose to do it just before the picture is saved. And it's a bit tricky because it's something that only worked in the desktop application of Evernote, so not really a web application. But that meant that the issue was not really solved because the old notes were still vulnerable. And something that is more worrying is hackers could downgrade their own version of the Evernote app, and then they were still able to create malicious notes and to serve them to to victims that had made the upgrade. And so the final fix was to encode or sanitize directly in the browser, and so all users who patched were safe. And so, because of this story, for many years, I thought, okay, the only way you have to fix XSS is on the browser side, because with this you're sure that all users are safe, and it's enough. So why would you take what would you fix it at another place? But a few months ago, so one thing that we do, that I do in my company, is some go and sees. So I will go and talk to one developer, one team of developer. We will have a look at that project and look at the code, and we will try to discuss how they protect against some flaws or some vulnerabilities. And we found out that, so it's a React component, and you can see here the dangerously set inner HTML. So with the name, you can guess it's dangerous. And for those of you who never played with React, it's the way to bypass the encoding in React, and so to have XSS in your application. So we thought, okay, it's not very important if the user is not able to control what is displayed in this component. And so this component was for some structured data, so it's used to display a JSON LD in SEO, so such as Google, to display some fancy components directly in the search page. And which is the thing which is really interesting is that this piece of code came from the Next.js, so the server framework for React. It came from the Next.js documentation. So the developers thought they were safe by using some code of the official documentation, but it's not the case. And it's not the case because some of the inputs came from comments from the Google Maps API. So let's imagine you're an attacker. If you added some JavaScript in a comment in Google Maps, the comment was fetched in the application, and the JavaScript was executed in the application. So, or it would have been executed because Google Maps did something that I thought was useless, is encode on the server side directly in the API. So even if we had not found out about this, we would have been protected thanks to Google Maps doing this. So of course we still need to sanitize or encode on our end, but thanks to Google, we had a defense in depth layer protection. Another thing that we can use stories to learn is that exploits are not always direct. So some vulnerabilities are not directly exploitable, but that doesn't mean you don't have to fix them, because attackers could be able to chain them to achieve their goal. So for example, some researchers found out about this cookie in the Zoom application. And as you can see, this cookie is related to CSP. So I won't explain in detail what CSP are, but so it's a mechanism to prevent XSS. Yet another layer in your defensive depth strategy. And so the fun part is that Zoom used this cookie to set up CSP to prevent XSS, but the attackers the researchers were able to find the next access thanks to this cookie. So how does it work? If you change yourself the value of the cookie on your browser, it will reflect in the HTTP response. So the N1s is one way to configure CSPs, and so the N1s that you put in the cookie would appear in the HTML response. And by many trials, they were able to build a payload that was parsed and executed in the browser side. So it's pretty useless because so it's what we call a self-XSS. You have to yourself go in your DevTools, change the value of the cookie, and then reload the page, and then you have the XSS. So to exploit it in the wild, you would have to convince someone to change their cookies. And there are two kinds of people. The people who do not know how to do it, but who do not know the impact, but they do not know how to do it, so it will be hard to make them do it. And people who know to do that, but they know the impact, and so they won't be convinced. And there is something called the same origin policy that prevents you as a user to modify cookies in another domain. But the researchers found out a second XSS in another subdomain of Zoom. So they didn't give the real name of the subdomain. They called it redacted.zoom.us. But they were able to, with a form, to inject JavaScript. And it's not really exploitable because nobody had an account on this subdomain, and there was no sensitive information. But as it's a subdomain of Zoom, they were able to craft a full payload in which they were able to change the cookie of the first vulnerability. And so, by delivering a link of a website they control with this form, they were able to have a full XSS in Zoom. So, how you can leverage it, and does it really work to tell stories? So, at Theodore, we send once every 3 weeks, we send a newsletter, and to all employees, in which we tell one of those stories. We explain how it happened and how the developers could have protected themselves. And one of the stories we told is, once again, it's related to the post. So in France, one day, people started to receive this in their inbox. So it seems like a legit receipt from the post. And in it you had a link and a QR code, and both of them would redirect you to the official post website. But if we have a better look at the URL, it's URL encoded. If we decode it, it looks like that. And in it, you can see a switch site, which can make you think of an open redirect. And this, which looks like another link, which is not as safe as the post one. So, in fact, you ended up, because of the open redirect, on the pirate site with a fake login form, and so you could give away your credentials. And so we told these stories, and literally the day we sent it, we got that answer. Thank you. Following your email, Morgan has corrected this vulnerability in our product, which contained the open redirect. So it's a big win for us. So the developers understood the vuln. They found out that they had it in their application, and they fixed it right away. So of course, it's a bit of luck. So to fight the luck, one advice is to have a lot of stories to tell, so that you have stories for every vuln or flaw that you could have to train developers for. And the more so because there is something that in France we call kilometric death, which is the more an event is close to you, and the more impact it will have on you as a person. So, for example, if one person dies just in your building, you will it will have a great impact on you. But if it's 2,000 or 3,000 kilometers away, it will have to be more and more deaths. So I don't have time for the. So I had 2 bonus stories, but you can go and speak to me afterwards. So it's about how you can leverage your own personal stories to touch more people. The key takeaways is so stories can help developers understand that security is fun. It can help them understand and remember flaws and vulns. It can help settle debates, even make you yourself evolve. You can use it to fight the optimism bias. It can help you make security a priority. And reveal developers' ingenuity. Because if they really understand what they're up against, they will find better tools to fight against that. So the newsletter I talked about, it's we send it even outside of Theodo. So it's currently only in French, but if many of you are interested, we could be interested to translate it in English. So don't hesitate to come and tell me. And we will release a book with those stories later this year. So if you're interested in an English translation, it's the same. Come and tell me about it. Feel free to give your feedbacks. Here's my LinkedIn if you want to connect. The link of the newsletter and the book if you have any questions.
I'll have 2 questions.
2.
One of these is the phishing thing.
That's a good question.
Yeah.
So I got a question.
Yeah.
I say, the fourth scenario. So say with self-XSS. Okay, you've got your infrastructure set up. Vulnerability scanners. You've got web traffic. If you push say you had an insider threat and now the concern in your company. For the self-XSS in the fourth scenario, if someone knew how to do that and did it maliciously, could you audit that, or is it as in them to run that script? If that makes sense. I know it's a broad question, but say someone had a self-XSS vulnerability, they knew the vulnerability, they used it to do something within the company to maybe get initial access. Would it be obvious in the current tools we have today? If that makes sense.
You mean? Is it able for an insider to leverage self-XSS?
So they had a vulnerable endpoint on which, or they had access to that XSS, right, and they could go into the developer console, run it.
So it will inject the JavaScript, but in their own session.
Only in the own session, so you wouldn't be able to go. You wouldn't be reflected on.
No, if it can be displayed on the web pages of another user, then it's not really a self-XSS.
Right.
The fact that it's a self-XSS is because you change your cookie on your browser, and it only affects your browser just after. So there are other ways to use self-XSS. For instance, with cache poisoning, where you will store the self-XSS directly in the cache.
Yep.
But a self-XSS just in itself, it's very difficult to...
Yeah, that's what I mean. I was just wondering, when I say would it be audible? It probably wouldn't be because of itself. Yeah, okay, thanks. Sorry, just
as we saw, it doesn't mean you don't have to go fix it.
I just wanted to ask, what sort of resources would you recommend for me, I'm a sixth form student, what would you recommend for, I guess, courses, reading material, anything to, I guess, increase our knowledge of stuff like this, XSS, scripting, etc.
So what I learned with is all the resources made by OWASP. All the resources made by OWASP, so Open Worldwide Application Security Project. They have many projects such as the Top 10, ASVS, which stands for Application Security Verification Standard, which is very exhaustive. And they also used to have some tools. I often use in my job a proxy called ZAP, Z-Attack Proxy, which is a former OWASP project, and which is very accessible and can help understand more and more about how AppSec works. Thank you for listening, and don't hesitate to